Steve Earn is head of developer relations at New Relic Incorporated. New Relic's product includes an all-in-one monitoring platform. The platform also includes both front-end and back-end monitoring solution. In terms of AI, it has a new tool called New Relic Grok that allows chat interfaces for analytics. The company has written telemetry SDK in Rust. The company has also used Rust to build several security scanners that are inspired by TruffleHog. Steve Earn also participates actively in CNCF landscape. His area of expertise includes cloud-native observability. Connect with him to discuss trends on observability, chaos engineering, and site reliability. Steve Earn is going to share with us introductory concepts in Rust. Before we start, here's best quote from the speaker. I just don't want to wake up 2 a.m. anymore. I need something that is performant, stable, and durable. At least I need to know where I need to fix.
This is an inclusive environment. In most Rust event you go, they assume you're a pro developer. They assume like, you don't know how to write a loop? What, you're dumb? We don't want that here. I really don't want that, because we will always cover Rust fundamentals. There are deep topics, especially for you if you're building stuff like your projects, or if stuff you want to learn on the side. Like for example, Dylan, I gave him a challenge. He needs to learn Rust. He did learn Rust, and he wants to present his point of view. One of the things I found, and this is the biggest critique in Rust, is the enablement, the knowledge of Rust isn't that great because the learning curve is actually quite high. So one of the feedback that I would suggest is if you want to learn Rust, take some time to revisit some concepts in C and C++ first. If you have Golang, like compile language experience, Rust is actually quite easy to pick up right there. As mentioned earlier, I haven't heard anyone actually talk about Rust in production yet in Singapore, but I already started hearing people in other regions. As mentioned earlier, I'll share a bit of my tips, what I would suggest if you want to learn Rust. For me, some people call the Rust book or the book. I prefer this thing called Rust Links. Rust Links. So you actually get it right. The Rust Link exercise. It's actually a hands-on kata that you kind of learn and you start seeing the beauty of Rust from there. Okay? That's my suggestion here. As mentioned earlier, I already have people reaching out. Hey, when's your next meetup? I don't know. You let me know. A lot of people just say, hey, I just want to present. I want to do stuff. I might do more, but I'm thinking around mid-November. I'm open to locations, speakers, and food and beverages if the location permits. I'm also very open to ideas in learning Rust. I'm seeing people like doing boot camps and stuff. I think this is not the place for it. It's more like neutral ground. You want to learn, you want to ask questions. I think this is the right place for it. Okay. So as mentioned earlier, obviously we're very late, but I know that. Again, as mentioned, I usually put 6 because I know people will come late. First, we'll cover some introductory concepts. It's okay if you don't know Rust. I'm learning together yourself too. I might say some really dumb shit, but it's okay. Feel free to correct me. After that, we're gonna get Dylan to share his experience, writing in Rust. He has experience in different languages. Then after that, we're gonna end the day with chili crab Rust. If you don't know what chili crab is a thing. It's a very Singapore thing. And if you look at the Rust logo, it's a crab. There, we will test your knowledge to see if you're listening, and we'll just end with 7:30, okay? As mentioned earlier, for people who just came late, this is your last chance. Please take out your phone, scan it. That's where you're gonna get the presentation. That's now it's in Google Slides. Just like 30 seconds before we move forward, okay? As mentioned earlier, if you're going to come for the next one, I will always make sure that the previous presentation is always available so that you can quickly recap before we move forward, okay? All right, as mentioned earlier, if you're keen to speak, if you're keen to help out in this meetup in future, whatever, feel free to kind of just tell me after this if you want, or just feel free to send an email. I cannot put Rusty Singapore, but I have to use the Malay word Singapura, because Singapore was already taken. Rusty Singapura.
There is another meeting?
I know, right? I'm like, okay, hey, hello. So we said, hey. So it's Rusty Singapura, okay? Not Singapore, Pura, the Malay one. All right, without further ado, let me get straight into it. So if you have the slides, you just go to the introductory concepts. Don't worry, like myself, I work in developer advocacy or developer experience. I understand sometimes you have to go really fundamental. Don't worry, I'll take good care of you. Let me just make sure of time. Okay, just a quick last reminder, please silence your phone, and we're going to start right now. So as mentioned earlier, if you look into Rust, it's impossible for me to cover all the fundamentals of Rust in literally 20 minutes. I will break it up in every part. In fact, I even challenge some of you, if you want to take certain section, you want to present it, as a way of learning, I highly encourage to do that, okay? Now, Rust is a statically typed compile language like C, C++, Golang. It has a very strong what we call type annotation, okay? Be mindful of that. The Rust C uses LLVM at its backend. It supports multiple platforms, x86, ARM, WebAssembly, that's the most common one. I can compile across Linux, Mac, and Windows. For me, as mentioned, when I went to Taiwan and I spoke to a few engineering leaders over there, hey, let's go for it, come and sit. Rust can be used even from firmware, bootloaders, smart display, mobile phone. I even started seeing more and more Rust being going into web and data science. This is like, oh wow. Right now, Rust is actually a lot in the blockchain environment, backend servers and command, like low-level stuff. But I'm seeing more and more data engineering, especially because of the rise of ChatGPT and all the AI stuff. People say Python is slow. There's sometimes people say, hey, module line is here. Heck, I even see people talk about Bun. But again, I've seen some of the developments actually moving there. For me, why, as mentioned earlier, I do look after the team. I do look after my platform. I just don't want to be wake up at 2 a.m. anymore. I need something that's performance, stable, and if something's going wrong, at least I know where I need to fix. That's one of the reasons why is Rust here. As mentioned earlier, I'm going to go to 8. Only 8, not a lot. Because once I go into lifetimes, we will stay here forever. Like the name lifetime. Lifetime is a very advanced concept in Rust. But again, even I'm learning it. We're going to go slow. Okay. First and foremost, that's a Rust code that you see on the left-hand side. Every Rust starts with a main function or main module called fn. Main, most languages have there. And your background, that's actually tell you the defines block scope of that area. Now you have let x equals tree, just means that variable bindings of x equals tree. Then you have print with a bang. What the hell is that? Right? We're going to talk about that later on. Then you have a number, so it just tells you we're going to do a print line. Number with a bracket, that's a placeholder that tells what x is going to pass into, right? Then after that, we redefine what x is, x equals to 5, and we do print line again to print that right there. Now, if you do this in JavaScript, can anyone tell me, if you do this in JavaScript, what will happen? Exactly. That's great, huh? JavaScript, who cares about it? It just works, huh? That's JavaScript. But people who know compile language, you know what is going to happen, right? Like type annotation right there. So the first thing is, I will not talk about mutability yet, but one thing that you'll find is I work with a lot of language. So it's like I was chatting with some of the folks. I predominantly work on Python, JavaScript, and Go. And you ever work with the compiler error before? You know sometimes like, what is this shit? And you copy and paste, you go Google, you look at Stack Overflow, and you copy that answer, you fix the code. That's very frank.
May I close the door? Use it, but it's scary.
Just in case people want to come in, sorry. Yeah. If not, you can move if you don't mind.
It's alright, it's very comfortable.
Yeah, no problem. You have background music over there. So as mentioned earlier, one of the things that I found, which is very refreshing in Rust, is the compile error is very helpful. It tells you what you need to do. Like for example, it says, hey, let x equals 3, the first assignment. If you want to change it, you want to mutate it, you should put what we call mutx right there. So as mentioned earlier, like for me, the best way to learn this is through, Kevin said, best is to go through Rust links. And the compile, when you write programs, it tells you very well. Now, one thing you have to remember about Rust, cannot work means cannot work. There's no maybe, okay? It's not like warning. No means no. No means no. It does that for specific reasons, for safety and memory stuff, okay? Now, the reason why it's giving you an error because of mutability, where we cannot transform, and that's the one thing that you will find when you work with Rust. Second one is, what the hell is that bang thing? That bang in the world of Rust is called macros. Right here. You take this out, it's a function, but once you put there, it's a macro. Macro, it's a very advanced concept. I'm not doing it justice if I'm going to explain what macro is. In fact, it's going to blow your mind. So, but what I'll tell you is this, it's very common to see things like this in Rust, where a lot of functions written in macros. What is this is known as meta programming right there. It's like code that writes other code. It's a very advanced concept. You don't actually see that in other programming language. If you're ever playing like Dota or League of Legends, something like that, usually like weird in the beginning, but very later in power late game. This was very powerful right there. An advanced concept, but you see this a lot, especially in Rust. Now let's go back again to mutability. By default, variables are immutable in Rust. Immutable. Remember of that. You can also use another one called const or constants to actually define that, but just be mindful of some of the rules around Rust right there. So when the binding is mutable, you put a mut. Once you put a mut, that's where you can start changing things already. Now, if you come from the world of C or C++, you probably heard the word called reference. Here, reference and pointers. This itself, it's a whole different topic already, right? Again, for part 1, I don't want to scare you off. I'd like to see you in the next meetup again. So I don't want to go too deep, but it is possible to create pointers and reference right there. And this one, again, if you ever work with C and C++, you see that right there. You actually create a reference based on that pointer right there. Okay. Now, let me introduce one of the first advanced concept, a very foundational concept called shadowing. Shadowing is actually quite an advanced concept, and especially when you're learning Rust. When I was learning Rust, I got tripped up. Like, what's going on? Shadowing is actually a very advanced concept. It's actually what we call variable shadowing. Now, let's play a game. Anyone want to guess what the value of this will be? 28, right? What the value of this would be? Shadowing, that's correct. But you notice the same variable binding, right? Because of the shadowing, you're borrowing that variable right there. So again, true. And what's this? There you go. There you go. So shadowing, you see this a lot, especially for people that learn Rust. Like for me, it caught me for a while. I'm like, why is it going this? Because of shadowing. But I thought you say it's immutable. Why the value will change? Because of variable shadowing. So you just need to be mindful of the scope when you look at the open bracket and the closed bracket, where allows you to redeclare a specific variable in the same scope using the same name. And this is quite an advanced concept, but this is available, especially when you start building really complex and advanced and really like what I call really complex production systems. No, variable masking. Just that's it. Yeah. Now, next one, data types. This is the one that often trips people, I find, especially in the world of Rust. Now, there's a lot of data types. I don't want to bombard you with a lot. And I think for now, just for introductory concepts, as I mentioned earlier, it's statically typed. It's a type language where they must know the variable at compile time. Be mindful, you have to declare up front, okay? Not like Python, not like JavaScript. So numeric, such as integer and float, non-numeric, boolean and character, then you have compound data type, which is array and tuple right there. One thing that will trip you out, especially in Rust, is you immediately see this signed and one unsigned. Again, especially there's a whole philosophical behind debate around it. What it really is just the bit, the length of that bit that you define. If you don't know, just starting out, just go with this. That's it, iterators. Now, if you're pro, if you start learning more and more, of course you can go a bit more. Of course, again, just data type itself is very deep, it's very extensive, it's very advanced here in Rust. But if you don't know, just start with iterators and off you go right there. Okay? Let me check on time. Conditionals. Now, conditionals, it's a very common, what I call building blocks in all programming language. C, C++, Python, Ruby, pretty much everybody, you'll see that right there. Usually it's pretty simple. If something, do something. Pretty straightforward, right? It's actually a branching that actually allows you to make decision what's right and what's wrong. Now, in Rust, to be frank, if you have programming language or you're just starting out, if else, let, those are common stuff. But the one that's really powerful, and especially if you're learning Rust, you want to pay attention, is the match expression right there. So For folks who don't know what match is, this is kind of like what I call switch, the switch statement in others. Now, a switch statement is highly debatable in the developer community. Some people say it's shit, some people say it's not shit. I don't care, actually, to be frank. You pick whatever you feel that's right, and the developer is working, doesn't curse at you. That's already good enough. But one thing that you will find, especially with Rust, is the way how they do match, because that's the only thing called the switch equivalent. It's very, very powerful, because now let's go play a game again, right? We have a let number 43. What do you think the output will be here? There you go, that's correct. But one thing that I like when I came into Rust is the condition or the pattern matching that you can write. It's actually quite advanced. That's actually really powerful, because think about it, in other language that you do, you have to write a lot of things like if, else, and a lot of stuff to go catch it, right? It's quite painful, it's quite annoying. But the way this is written is actually very elegant. Pattern is, especially when you do data validation. Like for example, for us in New Relic, when the data come into our ingestion pipeline, we need to make sure that data is valid, it's right. This is very powerful. I'm not saying Python you can do it, it's just that you need to do it in a much longer code. We actually use this to do data validation, especially when it comes through the ingestion pipeline. Now, again, let's do another quick one. What do you think the value is going to be?
1.
There you go. Great stuff. Looks like everyone here has very good understanding already on match. In fact, I feel like I'm not doing match justice, just talking about what we can do here. In fact, I challenge anyone here in the next meetup, if you want, take this, like really show some examples what people do in match. If you want to present, especially I have a friend, right? I call him my Jedi master. He's probably one of the craziest, most intelligent engineer that I met, and I saw him, the way how he used Rust with match, it just blew my mind. And I said that, Steve, this is kindergarten for me. I'm like, okay, all right. So especially for anyone, if you feel like you want to take match to the next level, go for it. Encourage that. Yes.
We can ask questions here.
Of course.
Okay, sorry.
Hey, go for it.
Yeah, so I'm a bit new to programming, but what happens when your match fulfills multiple conditions? What happens then?
Is there a question or answer?
I can answer that one.
Okay, you can answer.
I used in other languages before. So basically, it will just go the first one that matched, not the one below.
But I think in Rust, it will actually say, sorry, that's not unique, and it will fail. So Rust tries to be really
That's right. You want to present next time?
Yeah. Just one additional comment. So, I mean, pattern matching is also big in like F# and Elm and those languages. But the Rust compiler is even more powerful, because you could say case if your integer is greater than 10, you can say if it's 15 and greater than 15, and it'll tell you that you did not cover between 11 and 14, right? So it will actually run the logic. It will run much more than other languages.
That's right.
For checking the logic, and then only if you add all the cases, the REB actually quite well.
Yeah.
And that you got exactly all the cases right.
Yeah.
If you're missing one, it's not going to compile.
That's right.
Statements have to be exhaustive. Basically, exhaustive as well as mutually exclusive. So there's only one and one match.
Exhaustiveness you also get in the other languages, right? But the other languages, let's say you have U8s, right? And there's a finite set. The other compilers are not going to argue. They're not going to do as much analysis to prove that each individual case of that is. It's just going to be more dumb and be like, oh, you only handled integers and floats, but it could have been a bool as well.
That's right. So, for example, our developers here in New Relic, we have to write what we call defensible code. We have to write code that can withstand a lot of failures. Because as I mentioned earlier, if let's say customer sends us data, if the data doesn't arrive in our platform in 30 seconds and 1 minute, we get into a lot of trouble. So we do. That's why when I first saw Rust, like the way how it is written, like, oh my god, it's very elegant, it's very powerful. As mentioned earlier, I'm not doing this justice, but again, this is part one. If you do want to, if for anyone again that wants to take this topic to the next level, please let me know. We can actually go a bit more. As mentioned, this is just a very simple code. There's a lot of stuff you can write, like tuples, arrays, enums, pointers, structure. When I saw my friend what he built with his software, it just blew me away. It's a lot of stuff. You want to add something? Good? Okay, cool. Maybe you should present this up. Yeah, perfect. Great. Loops. Loops. When you build programs, at some stage, I mean, most likely you're going to do some form of looping. You know, you have an array, you have a data set, you want to go through it, right? Pretty straightforward. When you learn programming, even just starting out on your journey, you have loop through a specific set, while do something, then you have a condition, you break it out, right? Now, one thing you need to know, especially in the Rust community right there, Rustation would use what we call iterators to write a loop. Just be mindful of that. Again, it's just a technique, it's just an opinion, but for good reason, as mentioned, for good reason. So here's an example. We have a loop, a 4 element, and you want to look at the element in the array called 8, 10, 20, 30, 40, 50. What's the value? And you write something like this. 4 element in something that you want to go through the loop, and you pass through like this right there. As mentioned earlier, it's just a style, a very good technique that you see a lot in Rust. Why? Mainly for safety, concisiveness, also increase the safety of the code right there. You sometimes will see that as well, especially in React, right? Am I right? JavaScript, sometimes you see that, right? Yeah, so you just sometimes also see that a lot, especially when you do React. So this is something you see a lot in Rust. Lastly, before I wrap it up, let's talk about ownership. Ooh, this itself takes a while, huh? Takes a while. Even for me, it took me a while to really figure it out. Long story short, ownership is one of the most unique features that Rust has that actually solve why you don't need garbage collector. Now, as mentioned earlier, some people love garbage collector, some people don't. I'm not here to debate what's right, what's wrong. I'm just telling you, in the world of Rust, the reason why they're able to move away because the way how they do ownership. As mentioned earlier, languages like C, C++, and Pascal, you actually have to do the collection manually, while in certain languages, there's some automatic stuff that's kind of helped you along the way, like Java, Python, and Go, okay? So as mentioned earlier, Rust introduced a concept called ownership. Now, as mentioned earlier, it's okay if you don't get it this time. It took me quite a while to get it. I still don't get it, to be very frank. But I started to understand a bit more, and the more code you write, you get better. But what it is actually is just what we call ownership, who owns the variable right there. To understand ownership, you must first understand some memory fundamentals. The problem is, I also admit, I also struggle is I don't know some fundamentals before I got into ownership right there. First, Rust leveraged two different types of memory management techniques. First is the stack, and the other one's the heap. Stack, if you ever study data algorithms, data structures, you probably know, last in, first out, right? All primitive type has a fixed size, usually like an integer and stuff. Extremely fast because you know exactly the stack where it's going, and it's easy to manage right there. Heap is mainly for things where the size is unknown at compile time, aka like a string, right? And you need some form of what we call, you allocate the space in the allocate something into the heap. You mark it as a marker. Okay, I know that's where it is. That's an address. I'll come back time again and again. One thing you will notice, especially if you're learning Rust in your journey, vectors, strings are stored in heap. Slow is actually okay. It's actually not as really like super slow, but there's no guarantee of memory locality right there. So just remember, ownership, as mentioned earlier, I'm really not doing it justice, but just remember, every time when you declare something, when you move something, it has the owner of that particular, what I call, the execution of that code right there. When you move that value out, let's say I'm going to go into this function, I'm going to move here, it owns it, and somebody cannot come and grab that ownership anymore right there. So every value in Rust has an owner. There can be only one owner at one time, and when it gets out of scope, the value gets dropped automatically already. All right? Okay. This is the fundamentals, and of course, I haven't really go into depth on ownership right there. The next part will cover reference and borrowing, and I think Dylan will talk a bit about ownership later on, huh? Yeah. So again, I'm just setting up the scope for the talk that's going to go right there. Okay. So in short, as a recap, there's a lot, I know, especially if you're very new to Rust. If you already know Rust, sometimes it's good to just revisit some fundamentals. Later on, I think there will be some macros, right? I'm guessing. Then you have mutability, data types. This is something that, again, is very unique in Rust. They do it the way it's very elegant. And lastly, Dylan will cover a bit more ownership. Okay. With that, that's part one. Okay.